Okay. All right. Welcome everybody to the February Bergen Hub meeting of Sustainable Jersey. I want to share my screen so I can post the agenda here. And I want to start out with a few announcements. First, that I'm pleased to say that I received authorization just prior to the meeting to represent Allendale, the Green Team, from Councilmember Suzanne Lovasolo, our Green Team advisor. Also off topic, but announcement before the meeting, I am continuing to collect computer equipment. I had mentioned that in prior meetings. If anybody's interested, they have used equipment that they are going to discard. I'd be happy to accept it or pick it up, whatever's convenient for you. Cell phone, electronics, wiring, etc. I bring it to a facility in Rockaway, New Jersey, and they recycle it properly. And also, I did receive an email response from Tracy Zer's office this morning that she would be unable to attend, but asked that we forward information. We can send her the recording and minutes of the meeting and any materials. So that was
Mark?
positive. Yes.
Your second item, I'm continuing to collect computer, cell phone, electronic associated. I noticed that in the February newsletter that Allendale, the electronic newsletter that Allendale published, I noticed that. And you're planning on doing this for the whole year or a limited time?
As long as there's a call for it, I'll continue to do it. I make regular trips to this facility with components from my customer sites. So I'm happy to take it from residents and from hub members.
Okay.
But I make the trip anyway, so I don't mind doing it.
Okay. You might want to share that with the rest of the Bergen, and you're willing to swing by Bridgewood or wherever to pick
Yeah,
this
as long
up?
as it's a reasonable distance, I don't mind collecting from local residents.
Okay, all right. And I don't mind helping you out there, Mark. When I saw that, I almost fell off my chair because I think it's great. And so if you need a taxi to pick up stuff, I'm offering my services. I think that's great. I think we should share maybe the information that's on the Allendale newsletter with the rest of the Bergen County Hub or the towns that you want. And maybe they can have their towns, advertise it. Because I think a lot of people are disposing of electronics because they're not willing to go to the electronic waste recycling events that the county hosts. But if you're willing and I'm willing to go by their house and pick it up, we're probably going to get a good response, I think.
Awesome. Okay, thank you for that, Jim.
Mm-hmm.
Mark, do they also pick up spent printer cartridges or no? And can they recycle that or no?
No, it's strictly electronics.
Okay, thanks.
I see Amy has her hand up. You can unmute, Amy. You're muted.
Yes, thank you. Can you hear me?
Yes, I can.
I just wanted to update a little bit about Tracy. I had lunch with her a couple of weeks ago, and I talked extensively because I was so inspired after the last time I was at Bergen Hub with all that everyone has been working on for the styrofoam. And she told me everything that you all know already, but I did want to just mention a couple of things that you might not know. She did tell me that she had asked for a mobile densifier to be put in this year's budget.
Oh, good.
And I did follow up with her, and she did ask for some more information. So I passed along some of the information that you had all compiled, or Ken had put together, that had some of the. I think she was really interested in getting the numbers, the prices of the mobile densifiers. It didn't really. I had asked her if she, in what I had sent her, it didn't look like there were many options in the mobile densifier area, but I don't know if those companies had different sizes and stuff, but those were just examples. But she's a very smart person, so I'm sure she could do her own due diligence and look for some others just to give her a sense of what's out there. But that's, I asked her to please let me know, let all of us know when and if that gets in the budget for this year. And I had also said, because I believe it was recommended that there be 2 instead of 1 because of the size of our county. So hopefully,
Okay, well, that's part
we'll
of,
keep our fingers crossed that
Yeah.
may be moving in the right direction.
that's part of why I wanted her to be on the call, because that option has pretty much been taken off the table. And the presenter here from G2 Revolution is going to explain what is going to be in its place prospectively. And I was hoping she would hear it firsthand and bring a county perspective. Is
Oh,
what I
you
wrote
mean
to her
to
in
the
email.
mobile densifiers, the mobile ones are not a good thing anymore?
Oh, no, the one that we had been pursuing is not available for purchase any longer, but the
Oh.
service is available. And that's part of the presentation today, so you'll hear more about that shortly.
Okay, good.
But
And-
Mark, what I had conveyed to Amy was the list, the presentation that you gave BCUA of all
Right.
the different densifiers. And I
Yes.
also I updated the information that Tracy got and Amy got this to include the foam cycle
Yes.
mobile densifier, which Ridgewood has. So, I think we'll be jumping the gun a little bit. I know that that Scott is here from G2, and there's a really interesting plan. But I think we need to keep everything on the table until we have a plan
Absolutely.
that's really solid and moving forward, and the towns have agreed to.
Yes, I agree. I'm
We
not
may need
aware
a bit
that
of
Phone
both.
Cycle has an actual mobile unit. I know it can be wheeled around, but it's not the same type of unit that we were speaking about. In any case, yes, Ken, I agree with you that all options are still on the table. And I just want to do a short review before we begin with the speakers about the efforts that we've been making. There may be some people on the call that have not been privy to all of these discussions. So we are excited about the success of all of the drives that have been held, the public's response, the amount of material, and the fact that we're having a positive effect on the environment. We're trying to expand the efforts, including communication with the county and the state, to make this a bigger process. We want to have more municipalities participate on a regular basis and turn this into a regular collection instead of just volunteer events. Ridgewood is a perfect example that Ken just mentioned. They have already purchased a densifier. There are several other counties around the state that are already doing this on a regular basis. They allow the residents to bring the material to their DPW yards and they process it, and they have an arrangement with someone to collect the material. We are trying to use a sustainable method so that the footprint that we had by doing this on a volunteer basis, which entails moving the loose material instead of compressed material, is not the best way to do it. So we're looking for ways to have this processed on site, either with our own densifier or through a service. And that brings us to, yes?
Mark, if I can interrupt for a second.
Yep.
Correction, as far as I know, Ridgewood has not yet purchased a unit, but I had invited Sean Hamlin to join us tonight. And I see he's on the call, and he's the Ridgewood Recycling Superintendent.
All right.
So I see Sean unmuting. So when you're ready in your program, maybe you could invite Sean to give us a little update.
Yeah, I'm sorry. I thought in the last meeting you indicated that it was already purchased, so my mistake there. I stand corrected. You're still in negotiations, is that correct, Bob?
Sean, do you want to update us?
So, yeah, thank you guys for having me. So right now, we've been fighting with the town to purchase this unit for a long time, and we just kept getting, stonewalled at every angle. So we came up with a more creative angle, and we worked with Foam Cycle to get a unit placed on a 6-month trial.
Oh, okay.
We haven't started. We're hoping to have the actual. We had a snafu with the electrical installation because we're in a flood zone, and we had to have some specialized stuff put in. But I'm hoping to have it installed and up and running on Wednesday, and then it's upon us to just prove to the town that that we have the amount of styrofoam coming into the program that is enough to sustain the idea of purchasing for the big price. But I think we're going to do that because since Christmas, when the densifier landed, we have 2 tractor trailers full and 3 40-yard containers full, and we actually have the styrofoam unit full, just waiting for the unit to be operational. So we're going to spend about 3 days densifying, and then we'll record the data over the 6-month trial period. And then at the end of the 6-month trial period, I'm hoping that that the town says, okay, we really do need this.
Okay, Sean, so it's not a mobile unit, it has to plug in.
Yes.
Yeah, that's what I thought, yeah. Is there anything else you wanted to add, Sean?
Nope, that's it. I'm just here listening. If you guys have any questions, please, I'm here and I'll answer them.
Okay, a few more brief comments before I turn to our speakers. There are several densifier options that we have considered through our research. There are thermal densifiers, which heats the material at a very high temperature and melts it into almost a plastic block is what it ends up being. Jim and I from Allendale went out to Sussex County. We saw the unit in operation. We were able to use it ourselves, and we condensed a van full of material down to a very small block. It's an impressive 90-to-1 reduction in the material size, which allows for very efficient transport. The other option is a compressor, a cold densifier. That is a 60-to-1 ratio, but those units are much larger because the equipment to be able to reduce the material using weight requires a much larger machine. So that would entail either a building or a very large room to house the equipment. And in that research, I also came across a mobile unit that was being produced by a company called Braun Tech. And that excited me because you hitch it to a trailer, take it wherever you like, hook it up to propane, natural gas, gasoline, or electric, and you condense the material and then take the machine away and the material away. That equipment, the rights to that were sold to G2 Revolution. And Scott DeMuth is on this call. He will speak about the process that they are proposing to come to New Jersey with their business model, travel around to sites, process the material on site, and then take it away. And one of the concerns that have been raised regarding the thermal densification is the off-gassing and what might be in that gas that when you smell burning plastic, is that bad for us? Are we creating pollution? Is it carcinogenic, et cetera? So I reached out to my alma mater, and Alex Kolitsov, who was a professor of environmental engineering in the chemistry department, has offered to evaluate the material that I've received from two of the companies that produce these thermal densifiers and speak about their representations that they make that it's safe. So I'd like to start off with Alex and allow him to present his materials, and can take it from there. Alex, are you prepared to share your screen?
Yes, I'm ready. Thank you.
Okay.
So you should be able to see my PowerPoint.
Yes.
Okay, excellent. So then, as Mark has said, I'm at NJIT, well, the Department of Chemistry and Environmental Science. The times are moving, so our department has separated from chemical engineering around 2000. So we are now on our own. So I'd like to make a disclaimer here. Don't ask Professor for Timbal, because it's more like a firefighter, but I'll try to keep it short. But I will give a brief introduction. So polystyrene is made by polymerization process. You take these small molecules, which are called styrene, and you can use different types of chemistry to bind them together into these long chains to make polymer, which you can use to produce a variety of products. You can make cups, like this famous red cup, and it's pretty solid, right? You can have a block of solid plastic like that, or you can make it like a foam version. It can be done in many different ways, and basically this plastic would have small cells filled with air, and the amount of actual solid will be very small. Like Mark mentioned, it's really like about 1% of the mass of the material. The rest is just air. So now, let's say you order a computer, you receive it, you check that everything is okay, and then at this point, this packing material has finished its useful function, right? So you want then to get rid of it, and it's bulky. So ideally, you may want to compress it. So take this. Let me get the laser pointer. So you want to take this plastic and you want to compress it into something which is looks like this cup or even smaller. And that requires some force. So as Mark has said, you can compact it at room temperature, but this material is pretty solid. Yeah, it's foamy, but it's pretty solid, so it takes a lot of power and force to compress it. There's another solution. You can heat this material above its glass transition temperature, so it becomes rubber-like. So all of the polymers, they can be present in kind of two forms. If it's below glass transition temperature, it's solid. Above glass transition temperature, it's like rubber, basically like your tires. So then it becomes more pliable and it takes much less energy to compress it. However, if you heat it too much, you can actually induce decomposition, and then it will break down, and some of the initial like monomer can be released, and maybe some other chemicals can be released too, because you're not doing it in vacuum or in inert atmosphere, you're doing it while in the presence of air. Now for polystyrene, the glass transition temperature is about 100 degrees Celsius, or like this 212, I believe, Fahrenheit. And so it's not very high, right? So now let's see what has been done. I looked in the literature, and actually people did look at, let's say in this case, it's weight loss when you take a sample of styrene and you heat it to a certain temperature. So below about 300 degrees Celsius, nothing much happens, or maybe like 250. And then at high temperature, it starts to decompose, releasing decomposition products. On the right, you see the decomposition rate, and it just gives you an ability to see it more precisely. But basically, not much happens below 200 degrees, so which is good news, because again, if you heat it to just slightly above 100 degrees Celsius, it becomes softer. So what happens when you heat? Well, the same study, when you heat it up, the same study actually did analysis as a function of temperature, and you would see, well, this is your styrene, that's initial monomer from which polystyrene is made. So it starts to emit it at about 350 Celsius and above. There's also butadiene. It's kind of like a, similar molecule. It's released at 200 degrees and above. Then there's methylbenzene, it's toluene, another name, and then there is this styrene dimers. It's like two monomer units bound together. But again, in all of these cases, the temperatures are pretty high when you start releasing significant amounts. Well, when we look at these chemicals, we kind of care about we can look at them from two perspectives. One is obnoxiousness, the smell, and the other issue is toxicity. So, well, all of these are toxic to a certain degree. It all depends on concentration. And then in terms of smell, well, methylbenzene is not at a level when it's toxic, it doesn't smell that much. But this styrene, monomers, dimers, butadiene, they're pretty stinky. In fact, in our lab, we used, well, just because we had it on the shelf, we had it in some undergraduate experiments, and we decided to abandon it because if students spill it, it stinks. Now, questions we may want to ask, when we analyze data from different densifiers, what is the temperature of these compacting surfaces? Because certainly, even if you want to compact it at 100 degrees Celsius, the densifier will have to be much hotter, right? I mean, to have efficient heat transfer, your source of heat should be at a high temperature. And plus, formed polystyrene, it's a very good insulator. In fact, it's used for insulation. So, again, this means that the device which heats it up, it has to be pretty hot. And those surfaces which transfer heat to polystyrene, not necessarily they're heated uniformly. I don't know much about different designs of densifiers, but I heard like just 5 minutes ago that some of them are, well, you can fire it up using like propane. So I guess it's like some flame, and I would assume that maybe the heat distribution is not very uniform. Anyway, so what happened? Mark sent me results of analysis for 2 different densifiers, and those analyses were performed by different environmental companies, and it was kind of all done in the past. Based on the dates, it's like early 2000s, 2005, I believe, and so forth. So conditions under which this analysis were performed are not very clear. Like, it's not clear whether the densifier was running in a huge room, what was ventilation, or whether maybe it was like just outside. But I'll come back to that. Anyway, so let's look at the results. So I'm showing just snapshots of the data, just the most useful information. So there have been tables, and analysis was performed using this like TO15 method, which focuses on this hazardous air pollutants. The Environmental Protection Agency has a list. And so typically, you look for those. And so I noticed that everything was pretty much low. It was like within the limit of detection, more or less. So the only really large peak corresponded to styrene. And that's basically the stuff out of which polystyrene is made, right? You take styrene, you condense it into macromolecules, and you get your polystyrene. So that makes sense. So 170 parts per billion, is it a lot or not? Well, to answer that question, we can look at this table. So that's kind of regulations by different types of regulations like NEOS, OSHA, ACGIH. And here above, there's some description like what it means, but basically it's either recommended exposure limit or permissible exposure limit or so forth. So that range is between 50 and 100 parts per billion. And at least like in one case, the result came at 170. So it's above that limit, but it's not awfully high. So it's, let's say, it's almost okay for occupational exposure, just slightly above. Now, there was, this is the second, the results from the second analysis for a different device. And there, well, nothing came out. Basically, all of the levels were just within the detection limit, and including styrene. So, which is actually interesting. Those are really nothing, because like in the case of the first device, there were some other chemicals like acetone, which you may expect, because acetone is used as a solvent widely. I mean, you may have it in nail polish removing chemicals, or like some solvents, and there was some acetone here and some other things, but in the second case there was like really nothing. But they did some reference measurements. They performed like injection of known chemicals, and those came out correctly. So I assume like everything should be okay. So we could trust, and it should be certified lab. Now, why there's such a big difference? Well, maybe because first of all, it's different compactors. Let's say the temperature of those surfaces might be different. So the higher the temperature, or the less uniform the temperature is, you would have less overheat and more decomposition. Also different environments. Again, in both cases, there was just like very little information about the conditions, like what was the size of the room. In the second case, it said that it was a warehouse, but it didn't say like how big it was. Like the air exchange rate, distance from compactor where the sampling was done. I mean, all of these factors are important. It may actually create a huge difference. So that's something that is not known. Now, to conclude, well, we looked at two cases. In one case, there was really nothing. In the second case, there was some release of styrene, which makes sense, and that level was slightly above, allowed level, which is shown here. So, if you want to hear my recommendation, again, more information is required, but in order to, kind of, it's not enough to know this concentration. You need to know like under which conditions the sampling was done. But these levels, what I've seen, this 170 ppb, it's not that high. And let's say when you are some of the other chemicals which might be potentially released, but we're not released here, you might be exposed to higher levels when you're like mowing your lawn. Like let's say if you use like an old lawnmower, especially when you just a cold start, it stinks, right? And it releases all this like methyl benzene and other things which are components of gasoline. There's no styrene in gasoline, but it's a chemical which is kind of, it's not unsimilar to some of the gasoline components. So the conclusion is, if you do it, even if in the first case, if you do it in a better ventilated environment or outside, it should not be a problem. And again, a calculation can be performed. I teach environmental chemistry, and we run calculations with the students of this kind. Like, let's say you're in a shed or in a garage, and you're fixing your lawnmower, and you measure certain concentration of some chemicals, like carbon monoxide, and you know the air exchange rate in your garage. You can actually calculate the emission rate, and then based on that, you can make certain conclusions about like how would that affect the, let's say, your township. But based on these numbers, I don't think that's going to be a big deal. It will not change the background more than, let's say, a gas station, or let's say your neighbor with a clunker of a car, without catalytic converter, or with like a faulty catalytic converter. And just to give you like anecdotal example, in our building, a couple of years ago, we started having like a bad smell, not unlike polystyrene. And then we complained to environmental health and safety. They came, they looked through the building, they found the culprit. Basically, there was one of the labs bought a photopolymerization 3D printer. And the way it works, you have like a container with liquid. It could be something similar to styrene, in fact. And then, laser beam is used to polymerize this monomer to form a 3D shape. And this 3D printer is inside an enclosure, and there are some fans which circulate the air, and there are cartridges with charcoal which remove the emissions. But I guess they like never bothered to change the cartridge. And eventually, all of this stuff was just like entering the building. It was picked up by the ventilation and spread through the entire building. But after the AHS came and talked to them, they changed the filters, and everything was okay. So again, there are many options to consider. Again, running it in the open space, or maybe if it's a room, adding some enclosure with ventilation, exhaust. Like back in the days, I see it, we are all like not very young people. You remember those first photocopiers which had to have exhaust because they were producing quite a bit of ozone. They were big and smelled ozone. So I would say, well, it's probably not a big deal. So I'm done. I'm open for questions.
Alex, somebody asked a question. Was there any mention of the sampling time?
Yes, I think, again, I think two different types of sampling were used, if I remember. In one case, they were continuously sampled through like a cartridge. In the second case, I think it was a canister. You evacuate it, and then you just like open valve and you draw the air in. Sampling time doesn't really matter. It's just like matter of averaging how well you average over a period of time. But if your method is sensitive enough, it doesn't really matter.
Okay. All right, open the floor to questions for Alex.
Professor, I have a question.
Sure.
It's Christine.
Why do you think that there are no current studies on this? The second study was from 2006. I did not catch the year of the first study. But
Well, it's
why
not-
is there no current
It's not
studies
really
or
a study.
evaluation
Yeah,
on this?
I got your question.
Opinion.
Thank you. It's not really a study. It's that's not how it works. Basically, let's say you manufacture this densifier, right? And
I can't
you
hear.
try to sell it, and the client asks, okay, how much emissions would it produce? So basically, you just call an environmental consulting company. They send people who collect samples, send the samples to the lab. The lab analyzes samples, provides the results, and now you have kind of like certification which you provide with your equipment. It's pretty common. So it's not really a study. It's just like very standard method was used for this analysis. I mean, it's so widespread. This TO15, it's used like pretty much everywhere. Like you want to build a new facility, you call an environmental company who would like do projections, or let's say if you have a site which you want to repurpose, and that site was, used to be like some, they used paints, you would call an environmental firm who would do this kind of analysis. So it's not a study, it's just like routine analysis.
Okay, so as a group considering this, should we be concerned that the studies are over 15 years old?
The science, if those measurements were done, okay, so the science actually has been around. The method was developed, I can check, but it's been many decades. The method is very solid. It's been used both in scientific research, and it was used extensively by the Environmental Protection Agency. In fact, it was developed by the Environmental Protection Agency. So if the lab is certified, then the results can be trusted. Oh, here it is. It's 90. Well,
That was
the act
2006.
was 1990, basically.
What?
The
date on the top says 8/25/2006?
1990.
Test.
So that this method was probably developed to follow.
I guess, Alex and Christine, the question would be if the equipment has changed, then it
Oh
would
yeah,
require
certainly.
the test to be redone.
Each piece of equipment will require its own certification, because there are no piece which is the same, right? I mean, as you can see here, we looked at analysis provided for two different pieces of equipment, and the results are different. In one case, there are no emissions at all. In the second case, there is a level of styrene which is a couple of times higher than some regulated numbers.
So we could question the manufacturers if there's been any changes to the equipment since these tests were done.
Yeah. So
I see that,
Right.
Ken has his hand raised, and then John does also. Ken?
I think my question was mostly answered, but I agree that we certainly would want to see the analysis for any equipment that we would plan to purchase. That would be the one thing. And I'm not concerned about the age. I know the methods the methods are the methods. They haven't evolved in the last couple decades probably, but certainly the equipment, whatever equipment we would get, we would want to have this analysis done. And I guess the other thing, my comment, and I don't know, Alexei, whether you know any additional information, is, what do we know about, how it was collected? Was it done in a large building where it was diluted, for example, or in one case the building may have been ventilated, in the other case it was not ventilated. All these things, as you said, could make a difference, and we certainly should know that that bit of information should be attached as an addendum or something to these kinds of test results.
I've looked through the results. In one case, I couldn't find anything. In the second case, it said that it was warehouse, but without specifying its dimensions or, let's say, exchange rate of air. it was said like in which corner of the warehouse the measurement was done, but again, it tells us nothing because we don't know like where the equipment was relative to that. And I will look at it again. I mean, there are many tables with lots of data. I'll see if I can identify something, but on the first attempt, and maybe even the second, I couldn't.
Thank you.
And again, we know how things work. It's possible that, when it's kind of like in science, when you publish your data, you try to find the best graph, right? Like you conduct experiments, you get data, some graphs are better than others. You choose, the best looking. So maybe, they kind of use the best conditions for them. It's possible.
But it is a little concerning to me that if you need ventilation, which makes sense, knowing, the components of this very toxic material, part of, of course we want to protect human beings, but, just after the UN study today that came out again, saying that the emissions and everything that all the greenhouse gases and all the stuff that's going out into our environment is we have to drastically change our ways. So I'm more concerned about purchasing equipment that is going to, we don't want people to use gas lawnmowers anymore. So, this seems, I would have trouble purchasing a piece of equipment that's trying to do good, but at the same time might be causing another problem. And that's what I'm just wondering about, with the particles that lessen in the atmosphere. I guess what my question would be, I'm not really quite sure about the levels and what that does in our general atmosphere, if it would be harmful in that respect.
At this level, sorry. Yeah. Okay, I'll go ahead and answer the question. Yeah, at these levels, so if like in the second case, it was undetectable. I mean, like there's always something everywhere, right? Everything is soluble in water. The glass, which, this mark is soluble in water, just solubility is very small, right? So like there's always something somewhere, but it's a matter of like level. Certain chemicals, they're medicine at one concentration and they're poison at another. So in the second analysis for the second device, nothing was detected above the limit of detection. Like here you can see 0.05 or 5 ppm or 5 ppb. So in the first case, there was something. Again, if we are talking about someone working with this device every day, probably there will be some consequences. Again, there is a reason why there is this occupational exposure level set. Now, if when this goes into, like, let's say if it's someone inside the room, if it goes outside, it gets mixed with all of the air. So like for township, it's going to be like no effect, because again, the level will be very, very low. So, yeah.
Alex, yeah, I think you're addressing the concern well. The fact that it's there doesn't mean that it's there at a concentration that's harmful, because it's so extremely low.
Exactly.
That's why the agency sets limits on the exposure.
Right.
So the point is taken, but you also have to consider that we wouldn't be manufacturing anything if the level was so low, and yet just because you know it's there, you think it's going to be poisonous. Not to discount the concern, but if it's within the Clean Air Act limits, then it's considered safe.
Right, and usually, again, we're talking about trade-off, right, between like either we enjoy, riding our cars, and but then having electricity, but then we also have to keep in mind that, well, when we burn fuels, we release nitrogen oxides and maybe some hydrocarbons, and we get pollutants like smoke and ozone and things like that. Again, we do things to reduce those levels, and the US has been, over the last 50 years, there's a huge progress. So and we keep moving in the right direction. So
Okay, John, John, I
Yeah.
see you still have your hand
Yeah.
raised.
Yeah, I did. Alex, thank you for presenting on that. And, I'm sort of imagining that TO15 to be sort of an absorptive, desorptive GCMS headspace type of analysis, isn't it?
yes,
Okay.
GCFID can be used as well, but probably it's GCMS in this case,
Yeah.
right?
Yeah, and so the thing is that, yeah, I mean, how the sampling's done, I mean, exactly, what volumes and, where you're collecting samples of, a big deal. And, I had kind of firsthand experience with one of these types of thermal densifying type units. And it seemed to me like the concern would be like in a closed space without proper ventilation for this. And yeah, right over the thermal densifier, it's the odor is pretty strong. But I think designs I've seen have had like kind of local ventilation built in, and yeah, you just have to kind of minimize exposure. But I mean, in the grand scheme of things, I mean, the thing that we've always been told is like in the production of expanded polystyrene, they polymerize the styrene monomer, but they also are blowing it with like a hydrocarbon. I understand it's like pentane usually, and we keep hearing that in terms of like a dirty polymer, a commercial dirty polymer, that the production of I don't know about bulk polystyrene, but in terms of the blown polystyrene, which is a pretty large business across the country, it's fairly significant. It's like on number 4 for kind of the worst generators of pollutants. And so in terms of scale, the thing that concerns me more and more is that the manufacture of expanded polystyrene is pretty dirty. Part of our efforts is trying to reduce the production of like virgin polystyrene by encouraging companies to find uses for reuse of post-consumer polystyrene, and to potentially regrind that in and reduce the amount of new material that they have to make. And so that's one of our kind of goals here, in trying to promote good end uses for the collected polystyrene in our collection drives. Yeah, so my real question is like, I mean, because you have some sort of background in kind of HAPs, hazardous air pollutants, and the kind of EPA's kind of programs for controlling materials under CERCLA, or was it RCRA, and things like that. It seems to me that like the production of polystyrene is like probably really much larger. The concern of that is much larger in terms of its impacts on the environment. I mean, I imagine it's producing styrene, but again, it's got the hydrocarbon release. It seems to be like a large volume of pollutants that are done by that.
Well, there have been a significant improvement. There used to be time when freons were used to expand it, right?
Mm-hmm.
Then they were banned. Then people switched to just chlorinated chemicals.
Mm-hmm.
Actually, when I looked at the results of analysis, I didn't see any chlorinated chemicals there. They were all like below the detection limit. Yeah, so these days it's something like pentane, but pentane is it's not toxic. I mean, well, it's a hydrocarbon, not unlike like propane, like what you have in your propane tank. It's like propane and butane probably. Pentane is next. So it's kind of like almost what you use in your barbecue. So it's not really that toxic. If you have significant emissions, it's not that it's toxic on its own. It promotes the formation of smoke and ozone. But again, I don't think that emission from like when they blow this foam styrene at the plant, I assume they use some kind of way to scrub it, right? To recover maybe. And
Sure.
No?
I'm not sure.
And when you densify it, certainly there was some release, because these bubbles are probably filled with, in part, it's vapors, it's air and vapors of pentane, but the amount will be, I would say, relatively small. Again, if you compare it to emissions of especially older lawnmowers, emissions from even like cars which stink, these like stinker cars, right? A single car with such a car, a single car can emit as much as like 100 or 1,000 like normal brand new cars, right? So then relative to that, I think it's not very important. Or like gas station. Again, like when you're at a gas station, you have like your tank filled, you smell the gasoline. And, you know, pentane, well, probably there isn't much pentane in gasoline, but the hexane and octane and things like that, which are very similar, they're there and you smell it. And so, and you don't smell, if you try to crush foamed styrene, you will not smell that stuff. So the levels are very low. So that's probably not a concern.
Alex, you gave us a lot to think about here. Unless anybody else has a specific question, I did want to give Scott a chance to present. Does anybody else have something they'd like to ask Alex before we switch? All right, thank you again, Alex.
Can I just ask if the slides can be shared?
Certainly, I'll send Mark a copy of the slides.
Oh,
Absolutely.
thank you very much.
Yeah, and I have copies of the studies because I received them directly from the manufacturers.
And also, I will send all of the supporting material that I have found. You know, like there's an article and other things. So.
Okay. Thank you again, Alex.
Yes, thank you, Al.
Thanks very much.
Okay, Scott, are you with us?
Yes, sir.
All right, thank you for holding on to the call. Scott, again, is the president of G2 Revolution, a company that is in the business of providing a service to densify the material on site and then take it away to some processor that will use that material to create other items. So take it away, Scott.
Okay, thank you very much. First of all this is fascinating information. I love what this team is doing. So thank you for the opportunity to be sort of listening in on what you folks are going through and sort of all the information that's been presented. It's really quite an addition to the information that we already had. So thank you for that. So just briefly, because I think it was mentioned there, you know, there may be other people on there who haven't heard previously or maybe only got pieces of information. We are a company that has secured the rights to a mobile densification system from Brontech. We are a recycler ourselves. We have facilities in a couple of states, and we do actually programs nationally for a number of large retail and manufacturing clients. So we take in materials from all over the place. This sort of was the inspiration for the idea of trying to present a mobile service. Obviously, as you all well know, styrofoam presents its usefulness. It also presents some problems from a transportation logistics perspective. And so we secured this technology, and we have married it to basically a mobile-based platform. And this is a service that we intend to move forward with and provide to commercial as well as municipal customers. And the idea behind it is sort of roll up to whatever location where the stockpiled material is. We process the materials, feed it through the machine, it gets densified. It is a cold densification process. So it creates sort of densified material that will then be stored within the equipment that we have, and then it goes off-site. So the idea behind this is sort of a do-it-for-me model, and we basically have been moving forward with this concept. And then when I received information that this group was very interested, we sort of changed tack a little bit here and went in a different direction. And so we are looking at an Illinois rollout as well as hopefully with interest in New Jersey as well. So we just received our first unit. It's been installed, and actually within a couple of days, we have actually some media coming out to our location to do an article on the equipment. And basically our first unit is a trailer-based unit. So like I said, it sort of rolls up to the location. It's an enclosed trailer that has openable ports on it from the back as well as the side. And you know, you think of very much like a sort of an enclosed landscaping trailer or something like that. And basically, the material can be loaded into the machine. It can be processed, even if the weather is somewhat inclement. We have the ability to sort of have protection for our operator driver to be able to process materials. It can be processed remotely, or if it's next to a loading dock or whatever kind of staging area that can be agreed to, we can certainly work with folks at the facility to figure that out, how to do that. We are kind of going through several different pieces of this right now. So one of it is, as you can imagine, doing company registrations, sort of sales tax analysis and all that kind of stuff that's going on. I know that may not be an issue so much for you folks, perhaps being exempt entities, but in a general sense, we're looking at that. So we're sort of going through the business red tape, if you will. There have been some issues in terms of supply chain. For example, one wouldn't think it would be that big of a deal, but actually finding mufflers for the equipment to run the machine turned out to be somewhat of an issue. So we are going through just the standard stuff right now that a lot of other businesses are going through, coming out of sort of the pandemic and dealing with all that kind of stuff. So that's one piece that's in place right now. So we're getting that going. I think a very important other piece that you may be all very interested in is we do have a website up and running now, and there is an interest form on that website. And there's also frequently asked questions, sort of a very brief, you know, how does this happen kind of schematic is on there. There's a poster for what's acceptable, what's not acceptable. So there's a lot of resources that are on that website. Feel free to go to the website and to look at it. And certainly if it's something that you are interested in, please fill out the interest form, and we will collate that information to get a better idea of the details of what folks are doing and what that looks like. And that is live. So I can give you the website. It's styroamerica.com, just one word, Styroamerica. And basically that's that piece in there. So I would encourage everybody to look at that, and certainly provide us with any comments that you may have. I'm sure we haven't thought of everything in terms of questions and things like that, but it's a start, and can take a look at that. So we're working on scheduling to get people in, start looking at drivers and things like that. So again, getting a lot of that infrastructure and logistical piece in place for launching of the service. We still intend to look at somewhere between March and June. I think I said before, I think we're sticking to that. We've had some difficulties, like I said, but I think we can still make that happen. Cross our fingers, nothing comes out of left field from the rest of the world, quote unquote. But that is sort of what's on tap at this point. So that's a time frame. And hopefully, as we get some of these other things pinned into place, then we'll be able to update with a sort of firmer set of dates and things like that. So that's where we're at with the process right now. Pretty much the update that I have for you folks. I can open up the questions at this point. Mark, I'm still on the phone, so if anybody has a question, certainly, I can entertain.
Well, I do have a quick question, Scott. You mentioned that the unit is actually a cold densifier.
Yes,
So,
sir.
There
is no thermal unit on it.
Nothing. Okay. So do you know what temperature it's operating at?
I suppose we can. I suppose we can determine what that is on there, but yeah, I mean, there's no heating element on it.
So you are densifying the material through pressure and not through heat.
Yes, sir. That is correct.
Very interesting. Okay. Anybody else has questions? I will give up the floor here.
If I may, Mark,
Yes.
or Scott more particularly, from what I've gathered from the earlier conversations, it was said that to densify using force or pressure requires generally a larger piece of equipment than the thermal type. So I was a little surprised to find that Scott says he can put something like that on a trailer. So I just wondered if Scott wanted to sort of address that thought.
Sure. Yeah, it's part of that was part of the background and context when we were looking at technologies that was sort of appealing to us, that this is something that could be mounted inside of a trailer, weight-wise can be towed, or could be inside of a sort of like a box truck or something like that. And we have the ability to then move it around from location to location and operate that way. So it is, it's not a huge unit. I mean, it definitely has some size to it, but it doesn't take up the entire trailer. So we have space to be able to put densified logs in there and stack them up in the trailer, et cetera.
Bob, I was basing my comments on the equipment that I had researched and gotten pricing for. And they were all room size units. So I'm quite surprised as well when Scott told me that this was a cold compression. And a quick question, Scott, this is in a like a 40-foot trailer? What size trailer is it in?
I want to say it's 20 some feet long, the trailer. I'd have to check with my ops person on that for sure, but it's roughly like that. So think of sort of like I said, like a landscaping type trailer, something like that size wise.
Okay. An open air trailer.
It is not an open air trailer. It is an enclosed trailer.
Closed. Okay.
I mean, it has a ramp in the back, and it has a side door as well too. So, frankly, if it's nice outside, you know, everything is opened up and all that.
Okay. Larry, you have a question?
Yes. You had given specifications at the beginning of thermal, getting a 90 to 1 compression, and the cold press 60 to 1 compression. What kind of compression does this mobile unit get?
Roughly similar to the other cold compression figure that you mentioned on that. So it comes out the material as a log. It doesn't look sort of plasticized solid, depending upon the type of styrofoam that goes into it. So you can still see the beads, for example, on it. It doesn't get high enough temperature to be able to sort of change that chemistry-wise, I guess, in layman's terms, for that. But it definitely has a similar compression ratio to that.
Oh, would this, once shipped to the appropriate people, require further processing like the thermal ones we saw examples of? Look like they could be used as building blocks right away. Is this something that could be used right away, or it has to be processed further by whoever it gets delivered to?
It depends upon what kind of foam goes into it. For example, like the eggshell type foam turns into a very, very solid material, whereas like the packaging type foam is not as dense. Yeah, there would be different processing on the processor's end, but I've been assured that there's a market for both materials and they can use it.
Okay, good. Thank you.
Ken?
Yeah, my question is about the throughput, Scott. Just given what we've heard from Ridgewood, they've collected, I think, a couple of large trailers full within a matter of a month or two. What kind of throughput are you imagining would your device would be capable of?
So I think some specifications were provided in that study that had the different densifiers in there, and I want to say it was something on the order of 125 pounds an hour, something like that. Material. The point to the mobile is to be able to come out on a regular basis and service. And so if it is a situation where there is a lot of material, you know, multiple trailer loads kinds of things, you would have a hub to be able to go from to continue to process the materials.
You said you would have, I missed that last sentence. You would have what to allow the processing of all those materials?
Well, then,
A hub?
well, yeah, what we would do is we'd stage this. We're essentially working on having a hub to service northern New Jersey so that we can stage the equipment, and then we would have a central location to operate from to service customers appropriately.
Okay.
Scott, there's a question in the chat as to what the fuel is for the equipment.
So we have looked at various fuels. Part of the problem with supply chain is some things are available and some things are not. So right now we have a Honda motor for our first unit, and that one is specified for low emissions, so it can be used even in California. We can also run it on propane. We have looked at actually an entire electric setup. Unfortunately, I'm about the last guy in line to try and get an electric vehicle for a fleet purpose. So that's something that's down the road, but we like to work towards that and be able to run off of actually the vehicle itself to really cut down on emissions. So that's sort of a little bit further out there kind of goal for that. But that's basically what we're running it right now with a small engine.
So it's gasoline currently.
Yes, sir.
Okay. Christine?
Scott, I'm just curious what the plan is for data collection right from the beginning.
So one of the things that we built into this unit is it has a meter on it. And so as we're densifying material, it counts out how much has been sort of extruded out of the other end of the unit. And so by doing that and doing a back calculation on that, because we know the density and all that, we can then turn around and we'll provide a receipt or a trip ticket to the customer, basically saying, here's how much material weight-wise was processed, and we may get fancy and put in there stuff about, what's the equivalency in terms of cubic feet in the landfill or something like that. That's something that we're still mulling over. But you would have some kind of receipt for the service.
That's great. What about off gases or anything hazardous while the machine is operating?
So other than the actual motor itself, the machine itself, like I said, is a cold densification unit. I wouldn't even know where to find a study for cold densification or anything like that. Basically, we view this as it's not really warm enough to be able to create sort of an emission scenario from the mechanical action of the compaction. But I mean, I've looked around, I can't find anything that would, from a data perspective for that.
I think Alex had addressed that in stating it has to be at a certain temperature before it actually starts to off gas. Am I correct, Alex?
Not necessarily. Well, again, it depends on what we are talking about. So if you are talking about decomposition of the plastic, yeah, it has to be at a reasonably high temperature. But it may contain, like it was mentioned, like pentane, the blowing agent, which will be released even at room temperature. But again, I have absolutely no concern about those emissions. Like when you cold start your car, it will probably emit much more, comparable hydrocarbons than. And actually, this looks to me like a good deal. So these emissions, from the emissions perspective, well, it's non-existent almost. Like we are talking about, like if you call someone to cut down the tree, they would probably emit as much. Like you have a big truck coming, or people who go on like mow lawns. The primary focus here will be probably on like longevity of this equipment, and let's say if you buy it, how much the maintenance will cost. Again, if you have equipment which deals with uses higher force, then it means like there'll be more wear maybe on the parts. I don't know. These will be like good questions, like how long will it last, how much the like repairing it will cost, and things like that.
well, that's-
Also, there was a question about throughput. Yeah, throughput might be, again, for the comparable size, I would expect throughput to be a little bit lower than for the heated version. But then again, it doesn't really matter as long as it suits your needs. It's probably fine.
Yeah, well,
And I remember for cold, it's 60-to-1 ratio, right? And for thermal, it's 90-to-1. So it's actually not a very significant difference in the density of the final product. It's about like factor of 2, even less.
those are concerns that are outside of the question, because that is being provided as a service. We're not purchasing that unit.
Okay, so
Yeah, so, okay. Scott, I see you have your hand up.
Yes. Scott, you had mentioned that at an earlier meeting, somewhere was it was mentioned when we were talking about pricing and whatnot, that you're competing against the landfills. So the landfills cost is at a certain level, and you were looking to see where your business model would fall with that. Do you have any more clarity on that? Or have you been able to beat the landfills?
So yeah, that probably was not completely in the right direction there, if I said it that way, kind of thing. Generally speaking, the landfill is always going to be the cheapest option. It just is. And so what I'm trying to do is I'm trying to get in that ballpark, and I'm trying to get something that's comparable to what is already out there and can be a competitive response to some of these other things, like doing your own densification or having folks drop off and things like that. So I'm trying to get there. It's just a challenge because fuel changes and things like that. And what I don't want to do is establish something and then say, you know what, every month is changing kind of thing. So we want to get this right. So that's why we're trying to really, scribble in the notes and say, okay, what's the number going to be? Because everybody's going to ask that number. So we want to get this battened down really good. So you guys got a great comparable to go against, and you can say, okay, and then make your decisions at that point. So it's probably a little inaccurate if I said that before about that. I'm not really competing against the landfill. The landfill is always an option there. And I think that that'll always be the cheapest option until somebody starts taxing it differently. But I hope to be very competitive with alternatives that are out there.
Thank you for that.
Yeah, Scott, if I can add to that answer, what we have spoken about, and I think John Adams had done a calculation with how much of this material would fit in the back of a garbage truck. So in essence, how many trucks are we keeping off of the road, and how many trucks are not dumping into the landfill? So you're preventing the pollution of the truck driving. You're preventing the landfill being filled with the material. And in essence, you're saving a lot of money that's not being accounted for just by the simple thought of comparing it to a tipping fee. There's a lot more expenses that need to be accounted
Right.
for. Yeah.
Right. And certainly, if there's a purchasing situation, obviously you have the upkeep of equipment and all the stuff that goes with that on there. So we're trying to be competitive there. And yes, there are indirect costs that everybody has to keep in mind as part of this thing. But I'm trying to find value here and see what we can do to make that happen.
John?
Hey, Scott, John Adams. Good to hear you speak tonight. And I just want to make one comment. I got one comment and one question, but the thing I think we really find exciting about G2 Revolution and what it can offer in its service, for our county and probably several other counties here in New Jersey that are actively seeking ways of doing local densification of styrofoam. What's exciting about it is it kind of mirrors or patterns a service that we have that's offered to a lot of towns in our county for sure. That is mobile paper shredding. And so a lot of town officials, a lot of waste managers, a lot of recycling coordinators are going to recognize a service like G2 Revolution because it's like mobile densification of styrofoam. And you heard how much is collected just in one town, in the town of Ridgewood. It really adds up a lot. And they would really get this model of like a service of just coming right to site, densifying on the spot. And once you have it densified, you have a really, you have a commodity. You have a really material that can be stored and sold, and it's got value. It practically has no value undensified. So again, it's a great service. The thing that's important to us is, we'd really love to be able to put a pin on a date, between March and June, and just stick to it. And we could really put together a really good demonstration of your service. Be able to collect styrofoam from the whole county, bring it right to site, do it there right in the spot with your equipment. I think it would be a win-win type of a demo if we could commit to that. So that's something for you and Mark to talk about and let us know. But the question I had for you, again, very interesting news that your process is compression, of the polystyrene, expand polystyrene, and densify it by cold compression. That's really great. I had just a general question. You might not know this, but how dusty is it? I mean, you get this unit. You sort of sounds like it's in a trailer of sorts. But have you noticed? Does it just generally dusty, or the styrofoam flies all over the place, so you got a lot of particles of cells or whatever of polystyrene breaks up or gets into smaller pieces. But what do you notice about kind of all the stuff just in using it, how much your process kind of produces?
That's an excellent question, and one that we're actually working through right now, because there are some particles that do come loose in that during the processing. And so we are looking at a collection system to be on there right at the outlet, so that it can capture all the materials in there. After you run it for several hours, you start getting lots of little stuff all over the place kind of thing. So we are looking to actually have a capture system within the trailer itself too, as part of this process, just to, quite frankly, just people would, question, well, what's going on with all those little, things flying around and all that kind of stuff. So we are working on that as part of it. Yes.
Good. Okay. Thank you.
Ken, did you have a question? I saw your hand was up.
I did. I just one comment just to the group, regarding the kind of the throughput question. Scott says that should handle 125 pounds per hour. I was just looking at the spreadsheet that we've collected all of our styrofoam drive data on, and it looks like, I know it's a bit of a ballpark number, but we're collecting, around 100 pounds per collection. Maybe that's an underestimate, I'm not sure. But if that's true, then then this machine would be able to densify that within an hour or so, which seems, very good.
Yeah.
And I guess my question is, I just would want a little bit of clarity. You, Scott, you mentioned that if there were large amounts, you would envision a hub type of approach. Does that mean that towns would then bring the styrofoam to a centralized location? And I just wasn't sure if the other folks on the call here had that same understanding.
Oh, I apologize. No, what I mean by that is to have, you can imagine if there is quite a bit of demand, there may be a need for more than one unit out on the road. So we would come up with some kind of hub on our end to be able to have multiple units, or if for whatever reason one goes down or whatever, we can get another unit out there. So that's what I'm referring to when I'm saying a hub. That's sort of on our end to maintain the service, check on the units and things like that, and, general maintenance and stuff like that. So that's what I really mean.
Got it. Okay. Thanks for the clarification.
Any other questions?
I had a question for Dr. Kalzoff before we closed off, if it's okay.
Sure.
Yeah, so just, I just wanted to, review, kind of thinking over the data that you presented. And this is a kind of a truism with kind of the decomposition of polymer materials at high temperature. I mean, if there is more dangerous kind of air pollutants that are possible, they can happen at higher temperatures. And for example, there's an optimal temperature of above the TCG, above the melt point, to get this kind of magic temperature of like what they call melt flow. But we have seen some polystyrene recyclers using thermal densification that it looks like they're losing control of their temperature control. It seems like you see a lot of charring and discoloration of the polystyrene. I mean, like, to Foam Cycle's credit, their end product is a coil. It's very uniform in color. It's very milky. But we saw one operator whose material was really charred, burned. But just in general, from an air pollution standpoint, from a toxicity standpoint, if a recycler is going to high temperatures, that's not good, because, well, you're releasing more, styrene dimer or butadiene, or those things are possible at the higher temperatures. And so, I mean, I'm really excited to hear G2 Revolution has a cold press process. I mean, we sort of, have kind of scratched one area of concern off from organic volatiles, but on the other hand, we do have to deal with recyclers that do the thermal process, and there's always going to be that question about like the safety and that sort of thing. And one thing for sure is if it's too high temperature, it's not good in general. Would you agree with that?
Yeah, certainly. You made an excellent point. And actually, you mentioned charring. Yeah, that's a clear indication that the process is not optimized, right? Again, formed polystyrene is an insulator, right? So if you want to quickly compact it without using too much force, you have to apply a very high temperature, way above its glass transition temperature. But then, the bad point of that is that, well, you can overheat it and then it will char, it will decompose, and it will release all kinds of toxic chemicals. So it's really just, I guess, it's a matter of how much money you want to invest in the design, and also like quick and dirty versus well thought design, right? So it's always like that. So I mean, if you look at the market of cars some 50 years ago, this like lemons, right, which then eventually were removed from the market. And I'd like to make an offer actually before I leave, because I have lots of things to do. It's been a long day. I heard some comments, and often people confuse things like, let's say climate change, air pollution, which are not necessarily the same thing. You can actually improve air quality, but make climate worse and vice versa. And I actually do perform public talks, at nature centers and so forth. So if there's an interest, I can present a talk on about this. It could be online, it could be in person. I mean, it looks like we will be in March, the mask mandate will be removed, right? So I see. I'm interested in this from several perspectives. I mean, I'm passionate about what I do. I'm dealing with air quality. I study air quality. I teach air quality to students. I want people to understand these issues. And also, I want to promote NJIT. I mean, the school is changing. We have really a nice crop of students. The more people know about it, probably the more students we receive, or better quality students. So let me know if you're interested. I mean, you don't have to say yes now. Mark has my email, so you can reach out, and we can arrange time and a date.
Thank you again, Alex. Very interesting presentation.
And I'm really excited that it's really like how these things began. In fact, in the US, the movement to improve air quality began actually from grassroots. That's how things began. That's probably one of the best ways to do it. So thank you.
All righty. Thank you again, Alex.
Thank you.
I did want to mention to Scott And Christine, I hope I'm not stealing your thunder for something you wanted to say, but I got that email regarding 3 additional events that are being held to collect EPS. So Scott, you should know that it's an ongoing effort here, and we continue to collect a lot of material. So we'll be ready for you if you ever get out.
Okay, fair enough. It's there for me, huh?
It's there.
We all have plastic bags filled with it in our garages, and a lot of these events are very popular.
Mark,
So-
not stealing my thunder at all, but just to add, Earth Day is coming up, and that's a big trigger date
Yes.
for all of us. So having that densifier on a site before then or around then would be awesome.
Yes. Yeah.
Okay.
No pressure now.
Okay.
Let's get that
So,
muffler.
Yeah, right.
I did have one last question. Scott, you did mention, I heard you say egg cartons. I know the egg cartons are a different type of foam. Are you able to process that as well? In other words, if we separately collected different types of foam, including like the egg cartons, can that be done as well in a separate stream?
So one of the things that was sort of specifying out this equipment is that it could do things like the clamshells and the egg cartons and things like that. So that is something the unit can process, not just the packaging foam. So I've had some conversation with some folks that have like the food tray type stuff, things like that. So we can process it. And what I'm doing is I'm fine tuning how we would do that at a location. So I'm not sure yet whether it would need to be segregated. I will get back to everyone on that when we've got that figured out and dialed in. But I've got it right now at my facility, and we just feed it in the machine, and it cranks it out. So it can do that. It can do that form as well.
Okay.
Scott, I assume that information is on your website, but I also did post it to the hub. Scott had provided a graphic of the materials that are accepted and that are not, and it's quite a large range of foam that they're willing to process. So it's not just the packing. We could, conceivably collect food trays as well, as long as they were clean, and clamshells and egg cartons and the other materials that he has in his graphic. So very promising that we would be able to process additional materials potentially.
Yeah.
Okay. I did want to use the last few minutes of the meeting for business. So Scott, I want to thank you for a very interesting presentation. And we'll be sure to keep in touch. And I hope you can provide us with updates, saying that you'll be here tomorrow, if possible, if not by next weekend.
Gotcha. Well, thank you so much, folks. I appreciate it. And I'll be signing off here because you got other things to talk about. Take care. Have a good evening.
All
All right, Scott, take care.
Thank you. Thanks, Scott.
Bye, Scott.
Thank you, everyone.
Okay. Did we think we have time to do some committee reports, or is everybody exhausted? Does anybody want to make some announcements regarding either their green team or their committees?
I can make a very quick announcement just regarding electric vehicle exhibitions and shows and so forth. I'm working with Ridgewood. Their Earth Day event. They're going to have some electric cars on display, and I'm helping them to identify people who can provide them. And so this is just reaching out to the whole group here. If anybody knows anybody who has an electric car and they would like to bring it to that event, just reach out to me. The event is going to be April 10th from 11 until 2 p.m.
Okay. Excellent.
Good. I can just quickly talk about the plastics meeting. We have the recording online from the last meeting, so anyone can listen to that. And the next meeting, as I understand, correct me if I'm wrong, John, is going to be the 22nd of March on a Tuesday. Okay, and on the 23rd of March is the statewide plastics ban talk by Sustainable Jersey. So both those days should be of interest.
Excellent. Okay. Anybody else?
Mark, if I can piggyback on Ken's comment, I was going to announce to everybody that we are planning the Ridgewood Earth Day Fair. We've missed 2 years due to COVID, so it'll be returning this year. And as Ken rightly said, it's Sunday, April 10th, 11 till 2. Obviously, if people are going to bring their cars, they would need to arrive a little earlier than 11 to get in position. But beyond the EV, the planned EV exhibit, in the past, we've had green teams, environmental committees from other towns have exhibited at the event. And so I'll be sending out information on it, or I'll put it on Basecamp as well, if anybody's interested in exhibiting, or if they know of other organizations that would want to participate. So we'll send out the information. Thanks, everybody.
All right.
Yeah, thank you.
That's great. Mark, can you hear me? It's Suzanne.
Hi, Suzanne. Yes.
Hi. So just to piggyback on that, I wanted to let you know, Councilman Matt O'Toole had reached out to me the other day, and I just want folks to know that he has made EV stations kind of his focus area for the next year or two. So I definitely want to fill him in on everything Ridgewood is doing and, loop him into what's going on there. So I think that's great news.
Well, I just received an email regarding an initiative that I'll pass along to Matt to get funding for EV stations.
Fantastic. Yeah.
There's a grant that's available. I believe the deadline is coming up, so I'll reach out to him tomorrow.
Yeah, that's great because I know he's been really looking into it, and we do have that grant writer in town now, so that would be great.
Awesome. All right. Thank you.
Yeah, Mark, could you drop that into Basecamp?
Yes, I will.
Thank you.
And I did want to make a special mention of the efforts that Brian's been making in Oakland. And Brian, do you have any updates on the efforts that you've been making and materials that you've been producing?
Hey, thank you, Mark. Not too many updates at this point in terms of documentation. I can jump on camera really quick. If anybody's interested in bringing the program on board in their town, we're more than happy to help you do that, share the materials, do the onboarding, etc. John and I had a great meeting a couple weeks ago with the Northwest mayors of Bergen County. So the information seemed to be pretty well received with them. We updated them on the styrofoam-free business program and also EPS recycling. So it was a really fun Saturday morning, good topics, a lot of good conversation, good feedback. And it seemed like a couple of the towns were actually interested in adopting the styrofoam-free business program. So one of them was Glen Rock, the other one was Ramsey. So it seemed like there was definitely some interest there.
Awesome.
Cool. Thank you.
Thank you again, Brian.
Yep.
Okay. Is there any new business that anybody wanted to mention? All right, then we'll be looking for volunteers for the next meeting. I know this is everybody's favorite part of the meeting. So is anybody interested in hosting our March meeting? Oh, come on. No. All right.
Pick one.
I'm sorry, pick
I
one?
said pick
What
one,
I
yeah.
remember from my, one of my classes when I was in college, they say either volunteers or victims, one or the other. So, all right, well, hopefully before, is it always held on the last?
Mhm.
Okay, the
Yes.
last, yeah, okay, so we will,
Mark, if you want to put me down for April, I would be happy to be the air traffic controller for April, but March, I'm just not going to be able to attend.
awesome, all right, thank you, Scott.
Thanks, Scott.
And hopefully by March, we'll have somebody else. And I want to thank everybody. I hope you enjoyed the speakers.
Very much.
Thank you.
I wish you all a good night. Thank you for attending.
Thank you.
Great.
thank
Thank you,
you,
Mark.
Mark.
This is great.
Thank you, Mark.
Bye.
Good night,
Thanks so
everyone.
much.
Thanks a
Thank
lot,
you.
Mark.
All righty, good night.
Good night.